Welcome everyone to geometry. We're continuing on in section 2. Now we've already talked about lines. We'd like to talk about angles and angle measurement. So let's take a look at that. So we talked earlier about when we have two lines, they can intersect, and when they intersect, they form an angle. So what we want to think about is recognizing that what an angle is, and then again versus what an angle measure is. So let's see here. Our perspective, our geometric concept of angles is exactly what we've just described, right? It's an intersection of lines. When you're talking about trigonometry, you're talking about a rotation and that sort of a thing. So for our conversation within geometry, especially right now, we're going to be considering our conversations to be about when two lines intersect, whether they're line segments or rays, and then we have essentially a number that we can assign to that intersection, which would be our angle. So what is an angle? An angle consists of two rays, we're going to say. An angle consists of two rays. Again, you could use lines or line segments, that's fine as well. But to help with our definition, we say rays, so that way we can refer to their endpoint, and that these two rays share an endpoint called the vertex of the angle. So again, an angle itself is where we have two rays extending from a common endpoint called the vertex. All right. We can name angles in several different ways. So for example, we have a few triangles here, right? We have ADB, BDC, and we have triangle ABC. So we can refer to several different angles here. So if I wanted to refer to this angle right here, right, where this line and this line are, I could refer to it as angle A, because that's the unique vertex right here, right? So there's this angle. We can also refer to it as angle 1 by assigning a label of 1 to the angle, right? A refers to the vertex. So if I say angle A and there's only one angle there, hey, that's the one we're talking about. I can assign a label to the angle, call it 1, right? So I'm referring to the angle 1. And I can also refer to an angle by the points that are on the rays. So I can refer to the angle which has ray AB and AD by giving the angle as BAD. Let's see here, that one's there. Or I could refer to it as DAB, angle DAB. Or I can use C instead, which would give me angle BAC and angle CAB. So there's a lot of different ways that we can refer to this angle. Again, that's this line and that line. And their intersection is at A, or the common endpoint. So we have lots of ways to refer to this particular angle. However, if we wanted to use the same idea here, let's say at this angle, if I said angle B, that is extremely ambiguous because B actually has two different angles. It has this one and it has a second one. Give me just a moment here. It has a second angle given right there. So when I say angle B, which one of these two angles am I referring to? Well, if I want to refer to the blue angle, then I could refer to that as angle 2, and that would actually make sense. or I could refer to it as angle ABD. ABD. And that would also make sense. Okay, so we want to be clear. There are lots of ways that we can refer to an angle, and all of them are appropriate as long as it's not ambiguous. All right. So we've talked about what an angle is. Again, an angle is a pair of rays or a pair of lines that have a common endpoint called the vertex. So that's different from an angle measure, which is a number assigned to an angle. Okay, so the measure of an angle is a real number alpha, or a Greek letter alpha. The measure of an angle is a real number alpha given in the unit of degrees or degree, such that that number is between 0 and 360, where we're allowing it to be equal to 0, but not greater than or not equal to 360. So greater than or equal to 0, strictly less than 360. So we might actually find ourselves having a little bit of a problem, because if I have an angle, someone might say, if I assign an angle measure, what exactly am I referring to? Am I referring to this right here, or am I referring to this here? And a lot of times we might actually be familiar with, well, that depends which one is indicated. Well, that's not something that we necessarily practice here, right? The indication. So in geometry, what we're typically going to be referring to is the angle measure that is less than 180 degrees. So the one that's less than 180 degrees, let's see here, you get these words right. One is called minor and major. So the major angle is the one that's we would be thinking of the inside measurement. Sorry, the minor. The minor angle would be the inside, major would be the outside. So minor is the smaller, major is the larger. Okay, so we're typically referring to the minor. All right. So we gave a way to refer to angle measures, such as right there. And sorry, we gave a way to reference angles. And we have also a way to refer to angle measures. So if I want to talk about an angle, I have angle ABC. If I want to talk about the measure of an angle, that's indicated by M, the measure of this angle. Okay, so we have, if we go back up to this diagram here, we can see that this angle was given a label of 1, and this angle was given a label of 2, right? This pair of lines and this pair of lines was given a label. That label refers, right, it is a name given to the geometric figure, which is the angle. Here, when we see a Greek letter, typically what that refers to is the measure of the angle. So we want to recognize that we can name an angle, right? My name is Tim, but Tim isn't who I am. I am the person that is sitting here. Tim, name. And then also a way to measure, right? We could assign a number to a person like age, right? I'm 30-something years old. Excellent. So hopefully that clarifies what these are. Excellent. So geometric figures is a word that I've said and want to make sure that we know. Geometric figures it's a collection of points, and whatever this collection of points creates is a geometric figure. So extending the concept of sameness, when two things are the same, when two geometric figures are the same, those geometric figures are said to be congruent, right? Congruency is the idea of sameness when it comes to geometric figures. So yes, so we might say that the measure of an angle could be equal to the measure of some other angle. And when that is true, we would say that the angles are congruent to one another. Okay, so a little bit of difference here. This is a number, and two numbers can be equal to one another. These are geometric figures, and geometric figures can be congruent to one another. The idea of sameness. All right, so we're going to follow this up with a collection of definitions. Many of these you may have seen before, so we're just going to go through them relatively quickly. Of course, if you have any questions, feel free to send me an email and let me know. So two angles are adjacent, provided that they have the same vertex. They have the same vertex. That's not quite sufficient. And share a side. But also have no interior point in common. So what is an interior point? Well, if I wanted to talk about angles, let's see here, A, B, C, angle A, B, C here, the interior points would be all of these points here. So when we say that they have no interior points in common, that simply means that I'm not, if I want to say two angles are adjacent, I'm not referring to the same angle twice, right? Angle ABC and angle, let's say if we continue a little bit further, and we had, actually let me get rid of that a second. If we had point E, if we had point E here and we wanted to talk about angle ABC and ABE, they would actually be referring to the same angle, although named differently. So we wouldn't be talking about two, we wouldn't say that those two are adjacent, they're the same angle. Okay, so, and that's what this second part is clarifying. And then just a really quick question. I'm sure many of you know this already, but what does this indicate? Having this angle here, creating a square inside the angle. What does this mean? What does this mean? Of course, that it is the measure of angle CAB is 90 degrees. That's what that's referring to there. So whenever you see the square, you're talking about a 90-degree angle, or you're clarifying that it is a 90-degree angle. All right, so here we have, of course, ABC and CBD are adjacent because they have BC in common. Two angles, or two adjacent angles rather, two adjacent angles form a linear pair. Of course, if they're adjacent, they'd have to be that. But two adjacent angles form a linear pair if and only if, which can be shortened to IFF, if and only if their non-shared side, or non-shared sides rather, right? So A, B, C, and C, B, D are adjacent in this case, and they have the shared side of CB, or BC rather, and the non-shared sides are BA and BD. So if and only if they're non-shared sides, this side and that side, lie in the same line. Excellent. So in this case, of course, we would say that angle ABC and angle CBD form a linear pair. So for this figure, we have a linear pair because this side and that side lie on the same line. All right. A few definitions then. Two angles are supplementary if and only if the sum of their measures is 180 degrees. Two angles are complementary if and only if the sum of their measures is 90 degrees. These are things that I think that you're familiar with. If you need some examples, feel free to briefly visit Khan Academy. I'm sure that they discuss these things a little bit further. A right angle is an angle whose measure is exactly 90 degrees. Excellent. And so that's what we're referring to up here. This indicates a right angle. Excellent. An acute angle is an angle whose measure is less than 90 degrees. And an obtuse angle is an angle whose measure is larger than 90 degrees. Excellent. So 90 degrees seems to be at least a little bit important to us or of particular interest. Excellent. And why is it of some interest? Well, partly because we can talk about perpendicular lines then. So two lines L and M are perpendicular if and only if they intersect at right angles. At right angles. Excellent. So more postulates here as well. Two angles that form a linear pair are what? Well, if we take a look back up here at the linear pair, right, these two lines, or these two rays, lie within the same line. And what would this angle measure be? ABD. Well, that would be 180 degrees. So we know that linear pair, two angles that form a linear pair are supplementary. Cool. So here's something that might be new. A pair of vertical angles are a pair of non-adjacent angles formed by a pair of distinct intersecting lines. So that's a little bit interesting sounding. So let's draw a pair of intersecting lines here. Let's call this line L and this line N. Then vertical angles, watch carefully, vertical angles could be angles 1 and 2, right? This is an angle, this is an angle, and those are vertical angles because they're non-adjacent. Even though they didn't appear one above the other, right? It doesn't matter, left, right, above, below, they're still called vertical angles. Of course, if we were to look at A and B, then A and B would be a pair of vertical angles as well. All right. A pair, vertical angles are, do you know anything about vertical angles? How do their measures compare? Well, the measures of these two angles are the same, which means that vertical angles are congruent. Excellent. Okay, so that finishes up our conversation on angles, and we can continue with a conversation about lines. So we're going to go ahead and pause for a moment and actually make this this section into 3 videos. So I'll see you guys again shortly, where we can discuss parallel lines. It'll be a very short video. Hope you guys are doing well. I'll see you soon.